Hello everyone. Today we work on the Canadian Computer Computation year 2019 problem J5 rule 03. After reading the problem text, we know that it's basically a text processing based on three rules. We have an example here. The three rules are defined as if you have AA, you can replace it by AB. That's the first rule. And the second rule is if you have AB, you can replace it by BB. And the third rule is B to AA. And we have the initial text as AB. And here we apply rule 2, so it becomes BB. And then for the first B, we apply rule 3, it becomes AAB. And then for the last B, we apply rule 3 again, and we get to 4A. And then for the last 2A, we apply rule 1, and we get AAAB. So as you can see, based on the different sequences of the rules applied and the different positions in the text that the rules applied, with the same initial text, we can get different final text. And this is an explanation about how the rules are applied and from what position. And now we have the input specification. So the first three lines are the three rules. Each line contains two parts: the part to be replaced and the part of the new text. And then the next line, the fourth line, has three parts. The first is the number of steps that we should do, and then the initial text, and then the final text. And in the output, it depends on how many steps we need to do. For each step, we have a line in the output. And in each line of the output, we have three parts. The first part is the rule number that applied, and the second part is the position, which is the index in the text that the rule is applied. Keep in mind the position index starts from 1. The third part is the final string after this step is done. And now we have an example here. So the first three lines are the rules, and the fourth line is the number of steps, the initial text, and the final text. And here in the output, we have the first line as 21BB. So we apply rule 2 to the initial text, and from position 1, so we get BB. And then for BB, we apply rule 3 from position 1, we get to AAB. And then for AAB, we apply rule 3 at position 3, we get to AAA. And then for AAA, we apply rule 1 at position 3, we get to AAAB. As I said previously, depend on the different sequences of the rules that applied and the different positions where the rules are applied. With the same initial text, we can get to different final text. But also, with the same initial text, to get to the same final text, the sequences of the rules and the positions in the text may be different. That's why we have a possible output. So we can have different answers to the same input. Based on this, when we process the input, we need to track the number of steps and the result from each step. and we need to compare the result from the final step to the final text from the input, and if they match, we need to track back from the initial text and step by step to the final step and get to the final text. So in the program, we basically need data structure like this. We need a list, and in the list, each element is a pair. And in each pair, we have two elements. The first element is a list. And in this list, each element is a pair. Just follow me for now, and finally you will understand. So in each pair, we have two numbers. The number of the rule that applied and the number of precision in the text. And then for this pair, the first element is the list. The second element is the text. After this step, so we need such a data structure so that after the number of steps that are done, we know every possible final text, and then we can find this final text from the input in the list, and from this list we know the steps with which we get to this final text, so we can track back. This structure is a little bit complicated. Another option is to use a data class, but you basically need the same set of data. Okay, this is the analysis of this problem. It's a little bit complicated. If you have any questions, you can leave a comment.